Okay, so last time we looked at polynomial functions, we were looking at finding the zeros using synthetic division and then either factoring or using the quadratic formula, however else you wanted to find the rest of those zeros. And remember that those zeros are simply the places where the line is crossing or touching, and I'll explain that in a second, the x-axis. Okay. Now, and I said crossing or touching because it can do one of a couple things. So, and that depends on how many times a zero repeats. Remember when we talked last time, we said sometimes you have a multiplicity, so -4, multiplicity of 3. That means -4 occurred 3 times as a zero for that particular function or a solution for that function. So what we're going to do is we're going to look at how that affects the graph. Right? So if you're looking at a graph and trying to read the zeros, it's easy to do, and when you're sketching a graph and you have the zeros, it's easy to see what behavior the graph is going to have. So the first thing we want to talk about is what happens when a zero occurs just once. And if a zero occurs just one time, it simply travels across or through the x-axis. Right? If it occurs 2 times, then what's going to happen is it's not going to go through, it's going to bounce off of that x-axis, right? So if you think about if it happens once, remember that's kind of like a linear, just going through. With it twice, that's a quadratic, right? You get the parabola shape, so that's where that little bounce comes from. And then finally, if it occurs 3 times, then that gives you that little graph that has the wiggle in it, right? So the typical graph of a cubic equation, an equation where the highest exponent is 3, gives you that little shape that we're used to from when we looked at the parent graphs, right? Remember, it can also go that way depending on the sign. Then, from then on, any even number is going to give you a parabola shape, the U shape, and any odd number is going to give you that little wiggle shape. Depending on the sign, again, it's going to determine which way they're going. I keep drawing the parabola going down, which means that term would be negative. So, after you get these 3, then it just starts repeating. Even numbers do the same thing as the 2, odd numbers do the same thing as the 3. They get a little wider, bigger, which you'll see in a moment, and then they can wiggle inside themselves a little more, but in general, that's the shape you get. Okay? So what we're going to do is we're going to talk first about finding the zeros when you have a graph. Okay? So let's go to our homework so we can see that. Right? So in this particular question, they're asking you how many real zeros this function has. Remember, a zero is simply where the graph is crossing or touching the x-axis. It can occur more than one time, and you just have to look at the graph in order to be able to see how many zeros. And that'll also tell you what the degree of the equation is. So, if you look at this particular graph, you see that it crosses the axis there, there, and there. We see that they're counting in ones, so that's 1, 2, 3, 4, 5, 6, 7, 8, right? So, and of course on this side, it's just a number line, so on this side they're just negative, so -1, -2. So we see that it's crossing the x-axis at -2. So that's one of our zeros. It's crossing again at +1, and it's crossing again at +6. Notice it doesn't hit it and bounce off. That would tell you that it was occurring twice, and it doesn't hit it and then wiggle and then continue on, which would tell you that it occurs 3 times. Now these graphs will regenerate, so you could have any of those scenarios, right? But these then become the zeros of this function. Now they're not asking you for the numbers actually themselves, they're just asking you how many there are. So in this case, there are 3, but I wanted you to have a little extra knowledge because you're going to be doing something, you're going to be actually finding the zeros later, so you might as well get used to it now. Okay, so let's go back and answer that question. This function has 3 real zeros. Now, they don't always have 3. They can have more, can have less. Right, let's look at the next function. It says the function is defined by f of x equals x to the 4th, etc., and it has the graph as shown. So they've given you the graph, and they want you to graph to use the graph to factor the polynomial. All right? So if you remember, when we factored polynomials in the last one, what we have to do to get the factors is we first have to know the zeros. Right? Then, after we know how the zeros, we'll put those zeros with an x. And remember that anytime you're dealing with putting a number with an x or taking it away, then that's going to change the signs. So be careful, watch your signs. Also, watch out for multiplicity. Because if a zero occurs more than one time, then you're going to need an exponent. If it occurs twice, that parentheses needs an exponent of 2. If it occurs 3 times, then it obviously an exponent of 3. So first find the zeros, and again you're just going to do that by looking at the graph and seeing where it crosses and what its behavior is, where it's touching the x-axis. Then again put them with the x, make sure your signs are right, and then move on from there. So let's look at this particular graph. Blow it up so we can find the zeros, and then we'll sorry about that. Then we can find. So, and you see they even give you the numbers where this graph is either touching or crossing the x-axis. The first place is right here at -6, then right here at 0, and then here at +7. Now notice here at -6 it doesn't pass through, it hits -6, then bounces off. So what that means is that -6 actually occurs twice, right? That's what happens when you get a bounce. Now here at 0 it just passes straight through 0, okay? So you just get 0 one time, and the same thing happens here at +7, okay? Now notice how many zeros there were, 4 zeros, and this function started out as x to the 4th power. Remember, that highest exponent will tell you how many real zeros that a function has. So I expected 4 here by looking at the original function. That's going to come in handy later when you're going to be doing this backwards. Now, we have the zeros, but that doesn't tell us the factors. Now what we have to do is we have to put those zeros back with their x's to make the factors. So what I'm going to do is just erase here and use this space down here because I want to keep those zeros there and there so you can see. So remember, it's not going to be x minus 6 because when you put it back with an x, it's going to change the sign. We have -6 again, so that's another x plus 6. Don't worry about it. I know we can write that differently. Then we have x plus 0, and then finally x minus 7. And I just wrote x plus 0 because 0 is neither positive nor negative, and you'll see in a second it doesn't make much difference. And you see that these two repeated, and I went ahead and wrote them out long ways so that you can see where I was getting those numbers, but when we're typing it in, what we'll do is put that in parentheses and raise it to the 2nd power. You wouldn't just list all of these out when you could write it using an exponent. The other thing we need to clean up is this. If you have x plus 0, x plus 0 is just plain old x, right? Anything plus 0 is itself. And we're going to put that x in front. And it's not that the location has any specific meaning. When you're factors, it doesn't matter what order you put them in, but we just tend to put monomials, things with one term, in front so that we don't lose them, right? If you put it over here, you see it looks kind of funny, then you put another parentheses in. So we typically put those in front, which leaves last the parentheses x minus 7. And that is the factored form of this polynomial. So if you have the graph, factoring is really easy, right? Of course, we're not always going to have the graph, but sometimes you will. Okay, so let's see what's next. And I'm not typing in the factored form of the polynomial. You can. You know what it's like when I try to type parentheses. Okay, graph the polynomial function f equals 8x to the fourth. Then answer parts A and B. So what they want us to do is choose the correct graph. Now, I have no idea if this is going to do this on yours, but every time on mine, it keeps coming up with the correct one enlarged. I don't know if that's something I've done, but, well, maybe it'll happen to you too. But we're going to go ahead and graph it and pretend that it's not anyway, so let's see what happens. So what we have is just a plain function 8x to the fourth. Because that's a fourth power, that's even, it's going to give you that parabola shape. And because that's positive, right, it's going to open up. And so, can't be that one, that's an odd shape, right? Can't be that one because that one's negative. Can't be that one because that one's negative. So it has to be C, all right? And do you see what I'm saying about the parabola? Even though it's to the fourth power, we get the same shape, it's just wider across here. And it's probably, and many times it'll have some more wiggling going on in the middle of it, but we're not going to concern ourselves with that right now. You're just worried that it's a parabola shape for now. Okay? The reason it's a plain parabola is there's nothing added to, there are no more x's, so there's no x squareds, blah, 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 right? So it's just going to be that plain graph of a parabola, just like the parent graphs we learned last time. Okay, or a while ago, actually. Now, so, there we are. C, I can click on that just to make sure, but there you go. Now, the next question they ask you is about the function increasing or decreasing. And in this particular, remember that increasing or decreasing means what's happening to it as you walk toward it from left to right. So as we're coming across from here, we hit the function here first. And that function is going down, right? And then from here, it's going up. And the place where it splits is right there in the middle. In this particular function, that's 0, 0. And the reason I know that is because, again, remember this function was just plain old 8x to the fourth. There was no plus anything or minus anything, blah, 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 right? And so that means that it's going to go through 0, 0. Anytime you have just plain function, one term, then it's always going to go through 0, 0. Now, so notice that it goes down until you get to that point 0, 0, and then it starts going up. That's the vertex, the turn, right? But notice they want you first to type in where it's increasing. Well, that's this side, right? The side you come to second. So be careful about that. Don't do the wrong side. Okay, so it's increasing from this point, and then it increases forever as you go. So that means that it's increasing from that vertex, and remember that value of the vertex is 0, so parentheses 0, and it continues to increase forever, so that's positive infinity. This one I'll type in for you because I want you to see the next parts. Okay? And remember, it's a soft landing, it's not a stop, so 0 gets a parentheses even though it's a number in interval notation. Alright, and then it's decreasing, and let's see where it's decreasing. It's decreasing on this side, right? So it's decreasing as you go down here and stops decreasing at that 0. So remember that on this side, not negative 8, negative infinity, so for that it's decreasing there, so what we'll do is type that in. It's decreasing from negative infinity till you get to 0. So be careful the order they ask you the question in, because it's exactly the opposite of the way you'd see it when you found it on the graph, right? You found decreasing, it decreased first, then increased. Okay, graph the polynomial function, then answer parts A and B. Now this one is another one where they're going to give you multiple choice. And so what we have to do is find the graph. Well, the first clue we have for the graph is the biggest clues we have, period, are for the functions themselves. So we don't have to do any math here. All we have to do is first look at this exponent. It's a 3, right? Well, 3 is an odd number, so that means that it's going to be making this shape, right? The number in front of it is positive, so that means it's going in this direction, right? Remember the negative ones go like that. So so we're good there. And then also remember that +1. That +1 is the vertical shift. So that means the graph is up 1 from that x-axis. So now let's look at all the pieces and see if we can find the correct graph. Well, first of all, I know it's not C because that's a parabola shape. So it's got to be A, B, or D. They're all going in the right direction. They're all graphs of odd functions. But if you look closely, this one is going through 0, 0. This one is right there on that x-axis. This is the only one that looks as if it doesn't hit that x-axis. And if you look at the graph a little more closely by expanding it, it's easy to see that that's up about a little, well, they don't have a number on there, but it's the only one that's up above the x-axis, and this one has a vertical shift of 1. Okay, so the answer has to be D. Okay, so don't forget what we've learned before about those vertical and horizontal shifts. As a matter of fact, we're going to use both of those things in just a moment. So let's look at the next question. Sorry, now I know why. We didn't answer the following parts. It's increasing or decreasing. Now, if it's doing, we have this function, right? What you notice is it starts going from left to right. It's going up the whole length. Even though it seems to flatten out here, it really doesn't. It continues to go up. It's just a slight flattening. It's not really going down there. So that means that this function increases across its whole interval. So instead of typing that in, I'm going to just show the completed problem so that you can see what that looks like. And you can see the second part of that question too, which is about decreasing. So the function increases from negative infinity to positive infinity. It's always going up as you look at it from right to left. Which means if it's always going up, it can never decrease or go down. So the function is not decreasing on any interval of the domain. Okay? All right. Let's look at the next one. The next one, you should recognize this format, right? You have that f of x equals a parentheses raised to the third power plus 1. That means this one has a vertical and a horizontal shift, which means that we are going to definitely know the vertex or the turning point of this particular function, which is a great thing because it gives us a lot of information to be able to sketch this graph. All right? Oops, sorry, I didn't mean to be showing you the answer yet. So let me just get rid of the answer so that we can divine it for ourselves, because you need to see how the graphing tool works as well. So here we go. So we have our function, and remember that positive 3, remember it's our h and our k, is our vertex, right? So the vertex, our h, is the positive 1, but remember when you pull it away from that x, it becomes negative 1, and our k is positive 3. Don't change the sign there. We also see, if you look right here in front of the parentheses, you see a minus, right? Which tells us that this is, and it's an x to the third, so it's an odd function, and it's negative. Used to that kind of thinking, which means that odd functions do this thing, but since it's negative, it's not going to go that direction. It's going to go this direction. Finishes off by decreasing. Negative means going down in the end. Okay? Now, so what we're going to do is we're going to use that information to graph this. But let me show you the graphing tool and tell you why we have a little bit of a problem. Let me write down that vertex, negative 1, comma 3. our problem occurs when we try to get to the graphing tool. We know it's not a linear, not absolute value, not a quadratic, it's this cubic, right? But when you click on it, you see that this is called the 4-point cubic tool. So in other words, the only way to use it is to actually plot 4 points from the graph. Okay? Now, you could multiply that out and find all the zeros, but it's probably easier just to simply plug in numbers until you have enough points, right? Now, remember that we've already gotten 1 point, -1, +3. And the reason I put it down a little bit and not at the top is because I know where that is, right? So we look at our graphing tool, and -1, +3, okay, is right there. And what I'm going to do is I'm going to choose values for x that are on either side of it. I'm going to choose 1 from this side, and I'm going to choose 2 from that side. Remember, we had to have 4 in order to use this tool. So on this side, I'm going to choose -2. On this side, I'm going to choose 0 and then 1. Right? Those are numbers either to the left or the right of either more negative or on the positive side. Now, anytime you can, pick 0. It's a great number to use. It makes the math really easy. Okay? So those are the numbers that I've chosen. So what I want to do now is plug those into the function and see what y values I get to correspond. Right? Already knowing that I have 1, that 1, -1, +3. So let's just plug those into the function and work it out. Okay, oops, sorry about that. Now, here we go. So don't worry about the clutter back there. So our function, f of x, equals -x plus 1 to the 3rd power plus 3. So the first number I chose to use is -2. So I'm going to find f of -2. All that means is everywhere there's an x, plug in -2. You see why we did that a million times? Okay. -2 plus 1 is -1. To the 3rd power is still -1. And -1 becomes +1 plus 3, which gives you a y value of 4. So if x is -2, y is 4. So that's that point. Okay. Now let's do another point. Same function, but this time we're going to find f of 0. The reason we like 0 so much is it makes the x just go away when you do that. Let's see if that did better illustrated in some other problems. So all I did was replace the x with 0. 0 plus 1 is 1. 1 to the 3rd power is 1. So I get minus the opposite of 1 plus 3. The opposite of 1 is -1 plus 3 gives me +2. So if x is 0, y is +2. Okay? All you're doing is plugging it in, doing the math. Let's look at the next point. We chose 1. So f of 1 equals -x, oops, sorry, 1 plus 1 raised to the 3rd power plus 3. 1 plus 1 is 2, and 2 raised to the 3rd power is 8. So we get the opposite of 8 plus 3, which is -8 plus 3, which combine together to give you -5. So if it's 1, we get a y value of -5. Now we have 4 points that we can graph. Okay? And hopefully you wrote them down. I did, so we can go back and see what the graph looks like now. Go back to our graphing tool. We've already selected the right graph, so let's plot those points. Pay close attention to those numbers in the yellow because you really, some of these are hard to tell just by looking at the graph. So we got -1, 3 was our first point. -2, 4 is our second point. 0 gave us 0, 2. right? So that's there. So if you look, we've used 3 points already, and what we have is a straight line. And we know that this thing is not a straight line. So let's plot our last point, which is +1, -5. So that's down here. Notice now my MATLAB has drawn in the curve, and you even see where that vertex or that turning point is. It's going to put it in there in the proper place for you. So you don't have to know the vertex in order to graph these. But if you do notice, it just is the point that we said was the vertex. Okay? So we'll click on Save. Check our answer. There we go. Now we have a graph. They want to know where it's increasing and decreasing. Remember, as you're walking from the left to hit this, you hit it up here, and it's going down. Even though it does that little wiggle, it's still going down. It looks like it gets flat, but it doesn't, which means this one is decreasing over the entire interval. So I'll just show you that, how they type that in. If it's decreasing everywhere, that means it's never increasing, and if it's decreasing everywhere, that means from negative to positive infinity. Remember the interval notation. So you're seeing some things repeat in this course, right? Okay. All right. Now, let's go to the next one. Now this one, we're going to be discussing something called end behavior. In other words, what's the graph doing at the end of its lifespan on either end? Is it decreasing or is it increasing? You can make this very hard, or you can make it very easy. If you just remember the parent graphs and the shape and the signs that we've talked about so many times. So what you're going to do to determine the end behavior is first you're going to find the largest exponent. Which term in the polynomial function has the largest exponent? Then you're going to look at the sign of that term. And that will give you all the information that you need in order to be able to know what it's doing at the end. Because we already know something about the shape, right? We know that if it's even, we get a parabola, open either up or down. If it's odd, 3, 5, etc., we get those little wiggly shapes, right? And then we also know from the shape from the sign. That one's positive, that one's negative. This one's backwards. Negative, that one's positive. So you see that you know from the parent graphs what those shapes are. So, and if you look at these, they look very similar to the graphs, right? These are obviously parabolas on this side, and these are cubic or fifth power or whatever. We don't know. That's why they leave the line in the space in the middle. We're not exactly sure what they're doing in the middle, but we know the basic shape of them. So it's very even, very easy to see the largest exponent and the sign of that particular term. So if we look at this one, we see that the largest exponent is the fifth power. So this is 4x to the fifth power is the only term I'm concerned with right now. And since the exponent is 5, that's an odd number. And odd numbers do not make parabolas. So those two are out immediately. And the sign of that 4 is positive, so it's an odd positive. Well, odd positive, remember if the function is positive, that means it's doing this business. So it's down in the beginning, up at the end. So, therefore, the completed answer to this one has to be A. Right? So if you know those shapes, you're good to go. Let's look at this one. All right, again, finding the highest exponent is a 3, so that term is negative 3x to the third. The exponent is 3, which is an odd number, so that means it's going to be one of those wiggle shapes, not parabolas, so A and D are out. And if you look at the sign there, this time it's negative, and all that does is turn it around, right? Flip it over. So it's not B, it's going to be C. Okay, so you can tell by just knowing those parent graphs, those shapes, it's easy to tell what the end behavior is going to be. Okay. 6x to the 6 is our largest term, right? The one of the biggest degree. Since it's a 6, that's an even number. And since it's positive, even numbers are parabolas, so it can't be these little wiggly guys. And positive means that it's a parabola opening up, so it'll have to be D. Alright, so you get some extra practice. Some of you didn't do very well on that graphing section, but you get some extra practice doing those. Now be careful, because so far they've all been in the front, but that's not always the case. If you look at this one, the term with the biggest exponent is actually the one at the end. Alright, this is called ascending order. So make sure you're looking at the one term with the biggest exponent, not just the first term. That's a 10, which is an even number, and it's negative, right? So even negative means a parabola opening down. Can't be the squigglies. This parabola opens up, so it has to be B, the parabola opening down. So let's click on that, check our answer, and there you go. Okay, so notice there were 4 of those in the homework. That's great news because those are really easy, but it's really important that you understand what in behavior does, right? So didn't give them to you because they're easy. Give them to you so you can understand what's going on. Now comes the big ones. For the last 3, what we're going to be doing is we're going to be given a function, and then we have to actually graph it, which means that in order to graph these, if they're not already factored, and if you look at this one, remember if it was factored, that means that you would be seeing, oh, sorry about that. That means you'd be seeing a bunch of parentheses. This is just a function. So what we have to do first is find all of the zeros. And that's true whether it's factored or not. We have to first find the zeros. And this one's not factored. So when we're finding the zeros, this goes back to that synthetic division and then finding the and finding all the possible zeros, etc. Right? So we need to find all the factors of the number term. Well, the number term is 15, so that's 1 in 15. 2 won't go into it, but 3 does 5 times. And then all the factors of the leading coefficient, but the leading coefficient is 1. And so if you put these numbers over that, you're just going to get plus and minus each one, in which case I see no reason to rewrite them unless you're just trying to make a point. Okay? Now what we have to do is we have to test these using synthetic division to find them. So this is all from the last lesson. So we look at our function, we don't have any missing terms, we need to just write out our function and find the rest and find the zeros. So it's x to the third plus 7x squared plus 7x minus 15. Now there is no way to know which one of these 8 numbers, remember because it's plus and minus, will work. So what you need to do is just set up the synthetic division and give them a try. And 1 and negative 1 generally work more often than any others, but that's not always the case. So, but I always tried 1 and especially negative 1 first. 1 times negative 1 is negative 1, which gives you 6, times negative 1 is negative 6, which gives you 1, times that gives you 1, which is negative 16. That did not work. Okay? So we know that negative 1 is not a zero of this polynomial. Okay? Let's try positive 1. Bring down the 1. 1 times 1 is 1, plus 7 is 8. 8 times 1 is 8, plus 7 is 15. 15 times 1 is 15. 15 minus 15 is 0. So since we got a remainder of 0, one of our zeros is positive 1. So we know that positive 1 is one of our zeros. Remember that once you've gotten one of them to work, this is no longer x to the third, it's x to the second. So you can either continue synthetic division if you want to, you only have 8 things to try from, or, but remember some of them might repeat, or you could just factor it, if you're lucky enough to know the factoring rules, or you can use the quadratic formula. I don't care how you do it, but you have to find those other zeros. I'm just going to show you using quadratic formula real quickly. So it is x squared plus 8x plus 15. So our a is that number in front of there, so 1. B is 8. C is 15. I don't think you can practice quadratic formula enough. x equals the opposite of our 8 plus or minus the square root of 8 squared minus 4 times our a times our c, I'm going to need a calculator, all over 2 times 1. So negative 8 won't change. Take that parentheses, the radical off to the side. That's 64. Negative 4 times 1 is negative 4 times 15 is negative 60, which gives you 64 minus that. It gives you the square root of 4, and the square root of 4 is plus and minus 2 over 2 times 1, which is 2, right? So take the square root of it, we got our number. Now, remember that's negative 8 plus 2 over 2, and that's negative 8 minus 2 over 2. Negative 8 plus 2 is negative 6 over 2, which gives us a 0 of negative 3. Negative 8 minus 2 is negative 10 over 2, which gives us another 0 of negative 5. Okay? So that gave us our other two zeros. So now we know where that graph crosses the x-axis, which is really good information to have, because now we just need to find one other point in order to make this work, right? Because remember that we have to have 4 points. But if we know where it crosses the x-axis, we can use those to graph. X to the third means that it's one of those little wiggly ones, right? So there it is, the cubic tool. We have to have 4 points. Well, I know that it crosses the x-axis where x is positive 1, and where x is negative 3, and where x is negative 5. So right there, those 3 points. Now if you see, it gives me a parabola if I can just find one more point. And so what I'm going to do, you can choose any number for x you want to. The easiest number to choose always is 0 if you can. And what I mean by if you can is if it's not already one of the numbers on your graph. So we're going to choose 0, and what we're going to do is simply plug 0 into the function and find f of 0. So, and notice what happens. 0 cubed plus 7 times 0 squared plus 7x minus 15. 7 times 0, I'm sorry, minus 15. Look what happens. 0 cubed is 0, who cares? 0 squared times 7 is just nothing, and 7 times nothing is nothing. So anytime you find f of 0, all the x parts are going to just drop off, and the answer is the number. And that's why we like using it so much. So what we have to do now is just plot that new point that we have. Remember that point was 0, negative 15. So starting here, just going down till we get to 0, negative 15. Notice the numbers in the yellow will tell you exactly when you get there. Don't try to just count it out. Notice, pay attention to the yellow. And notice when we did, we snapped that into place, it gave us our line. Okay? We'll save that and check it. And there we go. Okay? All right. Now the next two, you get a little bit luckier. Because if you look at the way these are written with these parentheses in there, that means these are already factored, which means all you have to do is set each factor equal to 0. Okay? So first, again, we'll find the zeros. Okay? But we're still going to be one short, and I'll show you why. So our first factor is 2x, set that equal to 0. Our second one is x minus 3, set that equal to 0. And the last one's x plus 1, we'll set that equal to 0. To solve this one, do the opposite. Remember, to solve them, we just divide by 2, which gives us x equals 0. Here, we'll add the 3 to both sides, which gives us x equals 3. Here, we'll subtract the 1 from both sides, which gives us x equals negative 1. And those are our 3 zeros, which tells us that this function, the highest exponent, is x to the third. Okay? Because how many zeros did you have? 3. That means x to the third was the highest exponent. Okay? But remember, this is the 4-point graphing tool, so 3 is not going to do you a bit of good. So what we have to do is we have to choose one more number for x. And it can't be 0 this time because 0 is already one of my zeros. Okay? So, second step, choose another x. It can be anything, as long as it's not one of these numbers. So I'm going to choose positive 1 simply because positive 1 is easy to work with. You can choose any number you want to, right? So let's just move to, let me write those down so I don't forget them. It's 0, 3, negative 1. And now we're going to choose 1 and then put that in the function and work it out. So finding f of 1 gives us 2 times 1 times 1 minus 3 times 1 plus 1. All I did was everywhere there was an x, I plugged in a 1. 2 times 1 is 2. 1 minus 3 is negative 2. Oops. 1 plus 1 is 2. Just means to multiply straight across. 2 times negative 2 is negative 4. Times 2 is negative 8. So if it's 1, then the y value we get, f of x, is negative 8. Now, I used brackets because I had parentheses. If you want to use just bigger parentheses, that's fine. Put it in your calculator. However you get the answer, I'm okay with it. Just get the answer. So let's plot those points and draw our graph. Okay? And you could enlarge it if you wanted to, but remember you have the little graphing tool that's already going to enlarge it. Here we go. First thing, we're going to plot the numbers. Now notice how tiny these lines are, so use the yellow to make sure you're in the right spot. Okay? You can also move using the keys on the things on your cursor, the arrows on your keyboard, I'm sorry, because sometimes that's easier. So the first one is 0. The next 0 was positive 3, and then negative 1. Okay, we know all of those. Then the other x value we got was positive 1, negative 8. So put it at positive 1, go down to negative 8, which is right there, and you see that it automatically plots the curves for you, so we don't have to know all the vertices, etc. in order to be able to do this. There we go, check our answer, and there's your graph. Now, the next one, the last one, we're just going to choose the graph, the proper graph from the function. In order to do that, I need to kind of know the shape, but if you look at them, the shapes are all basically the same. So what we're going to do to graph that, or to select which one is the proper graph, is first, I'm going to see if I can do it just using end behavior. All right? Now remember, the end behavior depends on the highest exponent, but this is all broken up into factors. We'll just add exponents to find the highest exponent. So that's a 3 plus a 2 plus plain old x is a 1, of course. So that means it's to the 6th power. Okay? Well, that means both ends are doing the same thing, right? And if you look at all your x's, the x's are all positive. Now, not all the numbers are, but the x's are. So that means that this is an even positive function. So that means that the ends look like a parabola. Okay? So that's what they're doing at the ends. So if you look at the graphs, we may possibly be able to eliminate at least a couple from that fact, right? Maybe even be able to choose the correct graph. So if you look at these graphs, this one, the ends are going down on both ends, right? So it can't be that one. Ends are going down, right? Can't be that one. Here ends are both going up, so it could be that one. Here one end is going down and one end is going up, so it can't be that one. So without doing any math at all, except for adding the exponents to find out what the highest exponent would be, I know that the answer for this is C. That works every time on those particular ones where they give you the multiple choice, by the way. So learn how to do it. All right? My math lab is sometimes your friend. Okay, so that gives us the next to the last lesson done. We'll get that video out for the next lesson, and then you'll be ready for your next test. If you have any questions, be sure to email me. Bye.